Okay, we're coming back for the second round here about nuclear fusion. The sun, like I said, to recap, it's so big, it has so much stuff. The gravitational attraction of all the atoms in the sun squeezing it together, and in the center, it becomes what's called a nuclear furnace, where the atoms are getting fused together, and the energy it kind of has to work its way up to the surface again, which is kind of an interesting process of its own. But anyway, so let's get back to this process of nuclear fusion. Remember, hydrogen is number one proton, right? Sometimes it has neutrons, sometimes it doesn't. Helium is two protons, usually has two neutrons. Okay, so here we go. Four hydrogen atoms become one helium atom. Okay, so you have the atomic number, which remember you learned about this in sixth grade. I know you did. One proton is hydrogen, two protons is helium. Remember, proton has a positive charge, neutrons are neutral charge, electrons have a negative charge, okay? So what happens then is the four protons will fuse together to become two protons and two neutrons. The neutral charge, well, basically what happens is it becomes neutral because the positive charge from these protons gets shot away and goes off and becomes what's called a positron. It's antimatter. If you've ever heard of antimatter, yes, there is such a thing. The thing is, antimatter, when it combines with matter, the two things like unravel each other and release energy. They get destroyed and release energy. So I'll get back into that. And the one fusion is basically 26.775 microvolts, which is a small unit of energy, but you get a lot of them doing it. So this is the origin of solar energy. You don't have to write down this, even though it's in white. It's part of the diagram. But here's the deal I want to get into with Albert Einstein. But where does the energy actually come from? What is the source of the energy? Okay, so the atoms fuse. Why does that release energy? Let me explain right here by talking about this gentleman. You recognize him? What is his name? Say his name. Albert Einstein is correct. Okay, so you have Albert Einstein. And he came up with a very famous formula that I bet you guys know. It's the most famous. Now, you saw Isaac Newton's formula for gravity before, force equals blah, blah, blah. It's an equation, right? It's a super famous thing. Do you know what it is? It's on my tie. Okay, you got your pen? Okay, we're going to go over this a little bit. All right. Okay, on the paper here, anything I write, you got to write. Now, here's an interesting thing you might have noticed in earlier videos. I kind of noticed too. This pen is green, just like my green screen is. And so you can kind of see the pen acts like a green screen. I don't know if you noticed that in an earlier video, but I was kind of putting them together and go, wait, my pen acts like a green screen. Okay, but that's my pen. I like a green pen. Okay, so the famous formula that Albert Einstein came up with, let's write his name, Albert Einstein. Now, Albert Einstein, I'd like to get into his story a little bit, but I don't want to spend the time on it right now, okay? It's really pretty fascinating. He was a young man when he came up with his theories, just like Isaac Newton was a young man. He also wasn't actually at the university anymore. He had already graduated, whereas Isaac Newton, when he came up with his best theories, he was like at his aunt's villa during the plague when Cambridge shut down. Well, Albert Einstein had graduated and got his PhD, but he couldn't get a job as a physicist, and so he was working as a patent clerk. And in his spare time, he came up with the theory of relativity. Unbelievably amazing. Okay, but his most famous formula, you know it, E. Go ahead and write this and write it pretty big. Equals, write that. It's an equation. It's algebra. M. C. And what's the rest of it? Say it. You know what it is. Squared. E equals mc squared. You've all seen this formula before. What I want to do is teach you what that means, because this formula explains where the energy of the sun comes from. When you have 4 hydrogen atoms combining to become 1 helium atom, what this formula tells you that it will release energy. Okay? So stay with me here. Okay? And you can tell your parents about this at dinner tonight, because it's pretty darn cool. All right, so first you need E equals mc squared. You need to know what these things stand for. E stands for, what do you think this stands for? Go ahead and write it down if you know it. Stands for energy. That's right. Now, usually when I'm teaching this, I have a classroom full of kids and I can ask and they answer back. So I can pretty well predict. Most of you guessed that E stood for energy. Equals, what do you think M stands for? You are correct. It stands for mass. Okay, just like it stood for mass in Isaac Newton's equation, where you had mass 1 and mass 2. Energy equals mass. Okay, before we move on, this right here is the amazing idea that Einstein came up with. Energy equals mass. This is the formula. It turns out he came up with this concept that mass and energy are 2 sides of the same coin. They're like the flip side, 2 different aspects of the same basic stuff he called mass energy. Okay, so what you can turn one into the other. If you have enough energy, you could turn it into mass. If you have enough mass in a certain circumstance, you could turn it into energy. And this is what's happening in the sun. The mass of the sun, the actual weight of the sun, the mass, is turning into pure energy. Well, if you convert mass into energy, and again, this is a bizarro idea, but he really came up with it, and it's really true science, okay? If you could turn mass into energy, the c squared tells you how much energy you get. Multiply it, so this would be mc. I think you guys know enough algebra to know that it's a multiplication formula, but I'm going to put the x. Mass times c squared. Okay, again, when I've taught this before, most kids can figure out E equals energy, M equals mass. I want you to think, what do you think C stands for? And I want you to actually think about it, get your best guess, and on your corner of your paper, I want you to write what your best guess is, because I really want you to think about this. Do you know? Sometimes I have a student who knows. Most classes know. Okay, I'm going to go ahead and tell you. You might guess. It's called a C because it's constant. Remember I meant the capital G was the gravitational constant in the Newton thing? Well, what the idea here was Albert Einstein is the speed of light is always a constant for any observer. That the speed of light is a constant. That's why it's called C, because of that. So that's the speed of light. And most kids, when I teach this, are like, speed of light? What? That doesn't make sense. Well, it did. That's what it is. Okay? The speed of light. Now, when we get into a little more relativity again later, which we will a little bit, the speed of light is an amazing thing. It's constant for every observer. This is like a crazy cool theory and piece of future learning, okay? But now here's the deal about the speed of light. It's the speed limit of the universe. It's impossible to go faster than the speed of light. It's actually impossible to go the speed of light. Time itself will slow down to keep you from going the speed of light. The point is, how fast is it? What's the answer? Say it. How fast is it? Really super fast, okay? The truth is, it's 186,000 miles per hour? No, per second. 186,000 miles per second, or 300,000 kilometers per second. Which means if you shine a flashlight up into the sky in a clear sky at night, that flashlight beam, here's how long it takes it to go 186,000 miles. On your mark, get set, go. Done! It takes 1 second to go 186,000 miles. This is really fast. The point is, this is a big number. So if you get energy and turn it into mass and turn it into energy, you multiply the amount of mass you have by the speed of light, this really big number, and that tells you how much energy you get, which means you get a lot of energy. If you want to figure out how much energy you get, by converting mass into energy, you multiply it by a huge number. This is a really, really big number. Really big number. Okay, now, I don't know if I'm going to make you memorize it's 186,000 miles per second, but I want you to know it's a really big number. Oh, but are we done? Did we leave something out? That's right, we left out the squared part. It's not just a really big number, it's a really big number squared, right? 186,000 miles per second. Does that mean 2 times 186,000 miles per second? No, it means times itself. That means that it's a huge number. And I want you to write this down. I'm trying to think of a way to explain how big this is. It's a huge number. Okay? So the point is, a little bit of mass makes a lot of energy. Okay, a little bit of mass makes a lot of energy because this is the formula that tells you how much energy you get. Boom. That's what E equals mc squared means. That's Albert Einstein. And this is one of the most amazing discoveries ever in the history of science. And Einstein is like a stupendously colossal genius for figuring it out. Now, that's not the only thing he figured out, too. There's more to it than just that, the theory of relativity. But that's the part that's important for this lesson.